We continue curve sketching this time. This time we are considering asymptotes. Now look at this function, right? This function. We want to sketch this, the curve of this function. It's not easy. It's not easy. No. We analyze by factorize x 2 1, right? Plus minus. This one is 3x x minus 1 x plus 1. All right, that's easy. Now the reason of doing this because we try to find the vertical asymptotes. When x equal to 1, when x equal to negative 2, the function is not defined. And also that we can divide this function, you know how to divide polynomial by polynomial, right? Is equal to 3 plus minus 5 plus 5 x squared minus plus x minus 2. The reason of doing this division, we can get horizontal asymptote. Here we get a vertical asymptote, right? And also we try to find the derivative. The reason to find derivative is to find the maximum or minimum point. Now the derivative we use a quotient rule, right? So you get x squared minus 10x plus minus 2 minus 3 and x squared plus x minus 2 squared. I'll repeat again, the purpose of doing derivative, the purpose of differentiate this one, we try to get maximum or minimum point. And we know that this one equal to 0 means this one equal to 0, right? X squared minus 10x minus 3 equal to 0. So from which that x equal to negative 0.3 and a positive 10.3. All right. Now this is using a quadratic formula. You can have this, right? And so then we can find that x equal to minus 0.3 is equal to 0.602. The function of 10.3 is equal to 2.95. This is just preparation for our sketch of the curve. Okay. Now, do we need a second derivative? Second, we don't have to, because the curve is more or less determined. If you do need a second derivative, we can find the second derivative later. All right, now let's sketch the curve. Let's try to sketch the curve. Well, it's not easy to. It's not easy to draw a vertical line. Okay. Minus 2 and a 1, right? Minus 2 and a 1. Minus 2 is here. 1 is here. This is y. This is x. Now, vertical asymptote. What is a vertical asymptote? Vertical asymptote is that when x equal to 1, y is infinite. It's not defined. So at which we have, and negative 2. So these two are vertical asymptote. Sunny, do you see these two lines on picture? Okay. So these are 2, right? This is -2, this is vertical, this is +1, this is 0. So these are 2 asymptotes. Now when x approaches to infinity, y is approaching to 3. So 3 is my horizontal vertical. This is my horizontal asymptote. Very good. -3.6, -3, no, -0.3, right? This is a -1, 9.3 is 0.6 somewhere here. Where is the intercept? When x equals 0, y is equal to half. So this is 0.6. This is 0.6. It's not very accurate. This is 2. This is 1.6. Is somewhere here. This is 0.6. All right, and this is 0.5. This is 0.5. 0.5 is intercept. Intercept. When x equals 0, y is half. Then this is -1. This is 0.3. It's here. Okay. This is the point. Okay. What are other points you have? No. What are other points? This point. 10.3. 10.3 is somewhere here. So 10.3, right? Y is equal to 2.9. 2.9 is what? Somewhere here. 1 point, 2.3 points. Okay, the other points we can analyze by doing derivatives. Huh? Now, let's see. When x is approaching to -2 from the left, I'll repeat again. When x is approaching to this number from left, x is a -2.00001, right? Something like that. It's a little less than -2. Then this number is what? This number is negative. This one is negative because it's 2.0001. So it's negative, 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 positive. This one is negative. This one is negative. So it's positive. So positive, infinity. Understand? Let me repeat again. Maybe you don't follow. Look, when x is here approaching to -2 from the left hand side, so x is -2.0001, right? Very close to -2. So when x is this value, this is negative, this is negative, this is negative, this is negative. So the result is positive, but very, very big because this is almost 0. So the result is a very big positive number. So that's how it is. It's a vertical asymptote. Now, when x is very big negative, when x is a negative infinity, so this one is 0 because this square is a super big positive number. So this one is a positive. So this one is a very, very small positive number. Small positive number plus 3 is a little more than 3. So it's going like this. When x is a negative infinity, y is 3 and a little more than 3. This is positive. So little more than 3. So this is the asymptote. Okay, and then nothing between. So I can draw the curve like this. All right, this is the curve. Right. See, analyzed through the asymptote calculation. Now then x approaching to -2 from right-hand side, from this side. So x is, no matter how close to this point is, x is a -1.99999. This number is a -1.99999. So this one is a negative. This one is positive. Because this is 1.99 negative, the result is a positive value. Positive times negative is positive. This one is a negative. This one is negative because 1.99. Okay. So negative, negative, and negative, 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 positive. The result is negative. So it's like this. Okay. Approach it. No. Something like that. Something like that. It's negative, infinity. And we know that this value is what? Is the maximum or minimum. So in this case, must be maximum. It must be maximum. You know. And maximum coming down the 3 intercept. See, when x equals 0 is half, y equals half. Now, when x is approaching to 1 from left hand side, so x is more or less like a 0.9999999 positive. So 0.999 minus 1 is negative. This is positive. This is positive. This one is positive. 3 times 0.99 bigger than minus 1. So positive, 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 negative. So it's negative, negative infinity. So that's a negative infinity. Do you get it? When x is 0.999, 0.99991, okay, less than 1, right? This is negative, this is positive, positive, positive. So this one is positive at infinity. Why? Because this is almost 0. Almost 0. A number time divided by 0 is very big. So this one, it goes like this. Okay. Then x approaching to 1 from the right-hand side. On the right-hand side, x is a little more than 1. So this is very positive. This is positive, positive, positive. So it becomes positive infinity. Because this is very small. This is very small. This is 1.001. Minus 1 is 0. Very small number. So that afterwards the division is a very big number. So it's a very big number. Very big. It's asymptote. And then to this one, right? This is when derivative equals 0, this is the minimum. So it's more or less like the minimum. Not very. Yeah, something like that. The reach of the minimum, right? And continue. When x is infinity, positive infinity. So this is what? This will be negative. This will be positive. So the result is negative. The result is negative. Negative means very small negative. Very small number, but negative. So 3 plus a negative small number is a little less than 3. So little less than 3. This is 3, a little less. Little less. Little less means this. Yeah, little less. Of course, there's a point inflection here. When you find the second derivative, there's a 0 somewhere here. We can simplify by doing this. All right, so this is the curve. by considering the asymptotes. Well, not very easy, but they're definitely very interesting. Okay.